Hello, my name is Kanjiro Frank. I'm going to present this coursework on computer architecture and organization. Starting with the first question, which asks us to talk about the generations of computers. Let me start with the first generation of computers. The history of computers starts with the birth of the abacus over 5,000 years ago. After this, the development of the first generation of computers began in the 1940s, especially during World War II. Vacuum tubes were employed in the first generation of computers to perform calculations. The duration of the first generation was from 1946 to 1959. The primary generation computer was ENIAC, which in full is electronic numerical integrator and calculator. The first generation of computers was huge. They performed arithmetic calculations by exploiting vacuum tubes. Their programming was terribly troublesome. They consumed a lot of electricity. The first generation of computers had a lot of disadvantages. The four most vital computers were ENIAC and UNIVAC. UNIVAC was the first commercial electronic computer. IBM was the foremost widespread first generation IBM 650 was the foremost widespread first generation computer. Now the advantages of the first generation computers. The advantage of the first generation of computers was that these computers were quicker and could calculate knowledge in milliseconds. And their disadvantages were very numerous. These computers were larger, they consumed a lot of electricity. They made a result of heat because of the many vacuum tubes. They were not reliable. They were in need of constant maintenance. They couldn't be transported. They are very expensive. They used punch cards. They had limited programming capabilities. They had less work potency, and many others. Now let's talk about the second generation of computers. The period from 1957 to 1963 was a period of second generation computers. In this generation, transistors were used that were cheaper, consumed less power, and were more compact in size, more reliable and faster than the first generation computers. In this generation, magnetic cores were used as the primary memory and magnetic tape and magnetic disks as the second storage devices. In this generation, assembly languages and high-level programming languages like Fortran, COBOL were used. The computers used batch processing and multi-programming operating systems. The advantages of second generation computers. They were smaller in size compared to the first generation. They were more reliable. They used less power and they gave off less heat. They are faster compared to the first generation, and they are more accurate. Now their disadvantages. Even though they generated less heat than the first generation, they still needed a cooling system. They also required frequent maintenance. Their production for commercial use was also very difficult. They also used for specific purposes, and they also use punch cards for inputs. Now let's talk about the third generation of computers. The third generation of computers started in 1965 and ended in 1971. The third generation computers started using integrated circuits instead of transistors. The integrated circuit is a semiconductor material that contains thousands of transistors miniaturized in it. With the help of the integrated circuit, the computer became more reliable, fast, and required less maintenance. They became small, they generated less heat, and they became cheaper. The transistor was developed by Robert Noyce of Fairchild Semiconductor and Jack Kilby of Texas Instruments in 1958. So due to integrated circuits, the third generation of computers were much faster, efficient, reliable. They required less maintenance and small in size compared to the second and first generation. The third generation computers used less electricity, but they were still expensive and also required air conditioning for cooling. In third generation computers, high-level programming languages were used, such as BASIC, Pascal, Algol, Algol 6.8, COBOL, Fortran 2, Pascal P1/1. The punch cards were replaced with mouse and keyboard inputs. Now, the advantages of third generation computers. They required less space due to the use of integrated circuits. They produce less heat and require less energy. This led to fewer hardware failures compared to previous generations. In third generation computers, the punch cards were removed and the input was taken with the help of mouse and keyboards. They had an increase in storage capacity and gave more accurate results. They were more portable and had better speed. Now let's talk about their disadvantages. The computer still required air conditioning. To manufacture also another disadvantage is that to manufacture the integrated circuits, a sophisticated technology was required. Maybe like the first those first things that manufactured them. Also, maintaining integrated circuit chips were difficult. Now let's talk about the fourth generation of computers. After third generation computers, which mostly used microprocessors, fourth generation computers were released in 1972. Very large-scale integrated circuits were employed in these computers. As a result, they were dubbed microprocessors. A microprocessor is made of thousands of integrated circuits that are assembled on a single chip known as a silicon chip. Very large-scale integrated circuits contained about 5,000 transistors on a very compact chip and could conduct a very wide range of high-level activities and computations. Because these computers utilize very large-scale integrated technologies, the fourth generation computers had characteristics linked with the process of building an integrated circuit by merging numerous transistors into a single chip. This generation of computers had the first supercomputers that could perform many calculations accurately, and they also used networking and higher and more complicated programming languages as their inputs, like C, C++, DBS, and many others. Now let's look at the advantages of fourth generation computers. They were designed to be used for a wide range of purposes. These were general purpose computers. They were smaller and more dependable than previous generations of computers. They generated less heat compared to the previous generation of computers. In many circumstances, the fourth generation computers did not require a cooling system. They were portable and less expensive than previous generations. Computers from the fourth generation were quicker than those from also previous generations. The graphics user interface was used to provide users with better comfort. During this time, PCs became more cheap and widespread. Repair time and maintenance costs were also reduced. They were also created with the intention of being used in commercial production. In this form of computer, any high-level language can be employed. Now let's talk about the disadvantages of fourth generation computers. The fabrication of integrated circuits necessitated the use of cutting-edge technologies. Only integrated circuits can be made with high quality and reliable system of technologies. This made them very hard to manufacture. Let's talk about the fifth generation of computers. The fifth generation of computers were introduced after the fourth generation computers were invented. They are also known as the modern computers and are still in development and are based on artificial intelligence. In 1982, Japan invented the first generation computer system. Computers of this generation are based on microelectronic technology with high computing power and parallel processing. This is the most recent and technologically advanced computer generation. Modern high-level languages such as Python, R, C#, Java, and others are used as input methods. These are incredibly dependable and use the ultra-large-scale integration technology. Parallel processing hardware and artificial intelligence are used in this generation of computers. In the fifth generation of computers, all high-level languages are employed. The primary goal of fifth generation computer is to create machines that can learn and organize themselves. Artificial intelligence and parallel processing hardware are at the heart of this generation of computers. And artificial intelligence encompasses terms like robotics, neural networks, and many more. Advantages of fifth generation computers. These computers are far quicker than previous generations. These computers are simpler to repair. These computers are smaller than previous generations. They are also lighter and easier to move. True artificial intelligence was developed in this generation of computers. Parallel processing had progressed a lot in this generation, and superconductor technology has progressed. The disadvantages is that they are usually sophisticated, but they are very difficult to use. Also, problem is with the security and privacy. Is that they give businesses additional power to monitor your activities and potentially infect your machine. Now let's look at the second question, which tells us to talk about the evolution of Intel x86 architecture and ARM architecture. Okay, let's talk about the evolution of Intel x86 architecture. Intel x86 architecture has evolved over the years, from a 29,000 transistor microprocessor 8086 that was first introduced to a quad core Intel Core 2, which contains 820 million transistors. The organization and technology have changed dramatically. Some of the highlights of the evolution of x86 architecture are 8080. It was the world's first general-purpose microprocessor. It was an 8-bit machine with an 8-bit data path to memory. It was used in the first personal computer. 8086. It was a 16-bit machine and was far more powerful than the previous one. It had a wider data path of 16 bits and larger registers, along with an instruction cache and or queue that prefetches the few instructions before they are executed. It is the first appearance of 8086 architecture. It has a real mode and an addressable memory of 1 megabyte. 80286. It has an addressable memory of 16 megabytes instead of 1 megabyte, and contains two modes: real mode and first generation 16-bit protected mode. It has a data transfer width of 16 bits and a programming mode of 16 bits. 80386. It was Intel's first 32-bit machine. Due to its 32-bit architecture, it was able to compete against the complexity and power of microcomputers and mainframes introduced just a few years earlier. It was the first processor to support multitasking and contained the 32-bit protected mode. It also implemented the concept of paging. It has an addressable physical memory of 4 GB and data transfer width of 32 bits. 80486. It introduced the concept of cache technology and instruction pipelining. It contained introduced the concept of cache technology and instruction pipelining. It contained a write protect feature and offered a built-in math coprocessor that offloaded complex math operations from the main CPU. Pentium. The use of superscalar techniques was introduced as multiple instructions started executing in parallel. The page size extension feature was added as a minor enhancement in Pentium. Pentium Pro. It used registered renaming, branch prediction, data flow analysis, speculative execution, and more pipeline stages. Advanced optimization techniques in microcode were also added along with level 2 cache. It implemented the second generation address translation in which a 32-bit virtual address is translated into a 36-bit physical memory address. Pentium 2. It was able to process video, audio, and graphics data efficiently by incorporating Intel MMX technology. Pentium 3. It contained SMD instructions and supports 3D graphics software. It has a maximum CPU clock rate of 1.4 GHz and contains 70 new instructions. Pentium 4. It implements third generation address translation that translates a 48-bit virtual memory address to a 48-bit physical memory address. It contains other floating point enhancements for multimedia. Core. It's the first Intel microprocessor with a dual core, which is the implementation of two processors on a single chip. There's an addition of visualizing technology. Dual core 2. It extends the architecture of 64 bits to and core 2 quad provides for processors on a single chip. The register set as well as processing modes are 64 bits. Now let's talk about the evolution of ARM architecture. ARM was originally designed by Acorn Computers in 1985, with ARM originally standing for Acorn RISC machine. It was long before Apple became interested in ARM, and in 1990 Acorn Computers spun off its processor design team as Advanced RISC Machines, later renamed to ARM Holdings. The work between Apple and ARM eventually developed into ARM6, which was used in Apple's Newton PDA, which wasn't very successful and thus led to the end of Apple's usage of ARM chips temporarily. ARM quickly established itself as a company for mobile devices like Newton, but also with phones like Nokia's legendary 3310 from 2000, and Apple's iPod Touch from 2007. In 2005, ARM's market share in mobile phones was 98%, and this was before the introduction of the modern smartphone. Today, 99% of smartphones use ARM processors, and while this is also divided among different companies like Samsung, Apple, and Qualcomm, it's all the same ARM, which makes money off the licensing fees. ARM has also made inroads in markets traditionally dominated by Intel and AMD's x86 architecture, principally servers and PCs. Server chips such as Amazon's Graviton and Ampere's Ultra are mainly leading the charge in the data center, where Apple, Qualcomm, and Samsung are the primary competitors for x86 in the PC market. As of May 2023, ARM's market share in servers and PC stands at roughly 7%, 7% and 14% respectively. Additionally, ARM has also seen some success in gaming consoles such as Nintendo DS or even Nintendo Switch, which uses NVIDIA ARM-based Tegra X1.